Quadratic word problems. Let's look at our first example. We have the top of a coffee table is 3 foot longer than it is wide and has an area of 10 square feet. What are the dimensions of the top of the coffee table? Well, if we look at a drawing of this, we're talking about a rectangle with a width of W. If our width is W and we have 3 foot longer than it is wide, that would describe the length. So if the width is W, the length we would describe as W plus 3. And we know we find area as length times width. So if I have area equals length times width, we're told the area is 10. So we have 10 times the length of W plus 3 times the width of W. Then we could distribute the W, and we get W squared plus 3W. And if we put that in descending order equal to 0 or standard form, we have W squared plus 3W minus 10 equals 0. So now that we have a quadratic, we have two ways we could look at solving this. We could look at solving by factoring or solving with quadratic formula. Either way, we get the same solutions. So this one looks easy to factor. I'm looking for two numbers that multiply to negative 10 and add up to 3. Well, positive 5 and negative 2 multiply to negative 10 and add up to positive 3. So my factored form would be W plus 5 times W minus 2, and this is set equal to 0. Then I could solve my two small equations as W plus 5 equals 0 and W minus 2 equals 0. And I get the two solutions of negative 5 and 2. So we could have a width of negative 5 and a width of 2. Well, in context of our word problem, we're looking at a coffee table. So coffee tables not normally negative 5 feet wide. So that would be a great example of something that doesn't make sense in context of the word problem. Therefore, we would throw out the negative 5 and we would look at W equals 2. So if the width is 2, and the length would be width plus 3, then our coffee table, we would be looking at a width of 2 feet and a length of 5 feet. And quite often when we solve quadratics, we'll end up with this negative numbers that may or may not make sense in context of the word problem. So in order to get math problems correct, we need to combine two things: great math with answering the question being asked. In this case, answering the question being asked would mean you can't walk up to somebody and say that your coffee table is negative 5 feet wide. They will look at you strange. All right, let's look at a new example. So we have the product of two numbers is 640. Their difference is 12. Find the numbers. So in this case, I think we're going to need to start with two variables. So we have the product of two numbers. So let's pick A and B. A times B is 640. And we know their difference is 12. So if I subtract A minus B, I get 12. We have a system of equations. With system of equations, you need two equations, and you can solve two equations, solve for two variables if you have two equations. So I think I would take this second equation and solve it for A. So to solve for A, I just add B to each side. And if A is equal to 12 plus B, then A can be replaced with 12 plus B. So I'm going to take that fact and take 12 plus B and put it into that top equation for A. So I'm going to substitute A into the first equation. And now my equation is 12 plus B times B is 640. And that gives me an equation with just the variable B. Then if I distribute the B, I would get 12B plus B squared equals 640. Then I notice I have a quadratic. I have a squared term of B squared. So when I have a quadratic, if I'm going to solve by factoring or by quadratic formula, in both cases I need to get my problem into standard form, which is descending order equal to 0. So I want to subtract 640 from each side. B squared plus 12B minus 640 equals 0 is in standard form. So now I need to make a decision. Can I solve this easily using factoring, or do I need to use quadratic formula? Well, I think it would be a lot quicker to do factoring in this case. I think I can come up with some factors that multiply to negative 640 and add up to 12. And if I do, I come up with B plus 32 times B minus 20, because negative 20 times 32 equals negative 640. And 32 plus a negative 20 adds up to 12. Then I could set up each of my factors, b plus 32 equals 0, b minus 20 equal to 0, and I get two solutions. I get negative 32 and positive 20. So now I need to see, do these answers work in the original problem? Do they make sense in the original problem? Well, my two numbers multiply and give me a positive 640. So that negative 32, I'm already suspicious already as to that negative working, and 32 times positive 20, positive 32 and positive 20 will multiply to give me 640. What about the subtraction part? Can I do 32 minus 20 and get 12? I can. So it works, but I have to toss out the negative sign. So it put me in the right direction. It got me the great numbers, but in this case, I had to throw out the negative sign to make sure that my great math combined with answering the question being asked, and that helped me find my answers of 32 and 20. I just needed to throw out the negative sign. All right, let's look at a challenging one. Let's look at a hard one here. We have an equilateral triangle has sides that have been shortened by 12, 13, and 14 centimeters to create a right triangle. Find the sides and the perimeter of the original triangle. So an equilateral triangle, all three sides are equal. So like if one side was x, all three sides would be x. And then we change it to make it into a right triangle. And I need to make sure my final answer is asking for perimeter of the original. So despite my work, when I go back at the end, I need to make sure my answer is the perimeter of the original triangle, which the original is an equilateral triangle. So let's go through and look about what we have. We have an equilateral shortened by 12, 13, and 14. So if I look at my side lengths, if I start with x as one side, I'd have x minus 12, shortened by 12, shortened by 13, shortened by 14, to describe the sides of a right triangle. So what commonly known formula do we know has to do with sides of a right triangle? Sides of a right triangle, Pythagorean theorem. A squared plus b squared equals c squared. So I can take each of my three sides and put them in for a, b, and c. Remember, c has to be the longest side. So which of these sides is the longest side? Well, subtracting by 12 is going to make it bigger than subtract by 13 or subtract by 14. So side 1, this x minus 12 has to be the c value. So I'm going to plug those into the Pythagorean theorem. Then I can multiply these out. I could use FOIL. First outside, inside, last for x minus 13. I could FOIL out x minus 14 and x minus 12. And gosh, I get a whole bunch of factors here. Then I combine like terms. Now that I see I have quadratics, I want to get in descending order equal to 0. So I'm going to subtract everything to get everything to one side of the equation. You get x squared minus 30x plus 21 equals 0. Then, now that I'm in standard form, descending order equal to 0, I need to choose quadratic formula or factoring, and I'm going to choose to factor that as x minus 13 times x minus 17, which gives me solutions of 13 and 17. Now, we need to see, do these work in the original problem? Do they make sense? If I put 13 in, I'd have 13 minus 12 is 1. I'd have a side of 1. I'd have 13 minus 13 is 0. And 13 minus 14 is a side of negative 1. I'm not going to have sides of a right triangle be 0 and negative 1. So 13, not looking good. Actually, it looks bad. Don't use 13. 17, I'd have sides of 5, 4, 3. That looks great. So 17 is our answer. So that's the sides of the equilateral triangle. So if x is 17, meaning all three sides of our equilateral triangle are all 17, how would I find perimeter? Well, perimeter of a triangle, add up all the sides. I'd add up 17 plus 17 plus 17. So my equilateral triangle, the perimeter would be 51. So the sides would all be 17, and 17 times 3, or 17 added 3 times, would give you a perimeter of 51. All right, let's try a little bit easier one for you guys to try on your own. Go ahead, try this problem, pause the video here, and come back and see how you did. All right, welcome back. So you're making a rectangular flag for your favorite sports team. The number of square inches in the area of the flag is 9x plus 108. The number of inches in the length of the flag is x plus 12. What is the width of the flag? Well, we know if we multiply the length and the width, we get 9x plus 108. We know one of the sides is x plus 12, so we're looking for what number times x plus 12 would give me 9x plus 108. So we can think of this as like GCF or distributive property or just dividing. I think of it as what number times x is 9x? 9. What number times 12 is 108? 9. So the width of the flag is 9 inches. So sometimes with quadratic word problems, we run into problems that contain consecutive integers. So consecutive integers are just numbers in a row. So if I start with the number 5, I went 5, 6, 7. Well, if I start with 5, the next consecutive integer would be one larger, like x plus 1. And then the number after that would be the same as x plus 2. So if I started with 5, I'd have 5, 6, 7. Or if I started with 100, I'd have 100, 101, 102. And I could continue this pattern if I had 4 consecutive integers. I could do x plus 3, 5 consecutive integers, I'd have x plus 4. So consecutive kind of means in a row. Well, what about even integers? Well, if I started with the number 10 and I wanted to get to the next even integer is 2 higher, would be at 12. And the following number would be x plus 4, and I could keep going. So they're changing by 2's. If I start with an even number, adding 2, adding 4 will give me the next even numbers. And I could continue that pattern if I had more than 3 consecutive even integers. Now on the number line, even numbers and odd numbers are both 2 apart on the number line. So our setup looks the same. So for consecutive odd integers, if I start with 11, then add 2, I'd get to 13. That'd be the next odd integer. Then add 2 again, I would be at 15. So the setups look the same because if we start with an odd number and add 2, 4, 6, 8, 10, we get the next odd numbers. Or if we start with an even number, add 2, 4, 6, 8, 10, we get the next even integer as well. So the setup is very similar. So when you're setting up these problems, very important that you read carefully because your setup is completely different if it's just consecutive integers than if it is consecutive even or consecutive odd. So the first thing we have to do is read the question carefully and figure out which one we have. So let's look at an example. Let's say we have the product of 2 consecutive odd integers is 35. State all the possible pairs of solutions. So we got to read carefully. It says odd integers, consecutive odd, which means like if our first is x and we have 2 of them, then the next odd number would be x plus 2. And we can use that to write our equation. So we can do x times x plus 2 is 35. We could distribute, and we get a quadratic. And we have to solve quadratics by putting in descending order equal to 0, standard form. And now we have to choose between factoring and quadratic formula. And this one factors easily. I'm looking for 2 numbers that multiply to negative 35 and add up to 2. Well, positive 7 and negative 5 multiply to negative 35, add up to positive 2. Then I could take x plus 7, set it up equal to 0, x minus 5, set it up equal to 0, find my 2 solutions using the 0 product property, and I get negative 7 and 5. Well, if negative 7 is my first number, I'd have negative 7 plus 2, and I'd get negative 5. So negative 7, negative 5. Or if 5 is my first number, I have 5, and 5 plus 2 is 7. So all of my possible pairs of solutions, negative 7, negative 5, and positive 5, positive 7. So make sure you have both answers listed there. Okay, you guys try this one on your own, see how you do. Pause the video and come back and we'll check your work. All right, welcome back. So there's very similar steps to the last problem. This one we have even integers. We read carefully consecutive even integers. So if our first number is x, the next even integer could be described as x plus 2. So we'll write the equation x times x plus 2 is 24. Distribute the x. Then put our equation in standard form. Now we can factor. This one looks easy to factor. I'm looking for 2 numbers that multiply to negative 24 and add up to 2. And they are 6 and negative 4. Then if I solve x plus 6 equals 0, x minus 4 equals 0, I get negative 6 and positive 4. So my first set of answers, if x is negative 6 and then I add 2, I get negative 4. So I have negative 6, negative 4. And my second set of solutions are if x is 4, then 4 plus 2 is 6. So all of my possible pairs of solutions, -6, -4 is one possible pair, and 4, 6 is my other possible pair. And you can run into ones that are more complicated, that might have more than 2 even, more than 2 odd, more than 2 consecutive, or they might give you different relationships to write your equation. You just have to read carefully and make sure you set up your equation properly. But the setup for even and setup for odd are the same, and just read carefully to see which of these 3 kinds of problems you have. Have a great day. OUT spells out.